Hello and welcome to today's Retrieval Market Demo Day. Today's date is Wednesday, the 27th of October, 2021. On the schedule for today, we've got an incredible lineup. We've got Zhenyang Shi speaking about the FCR he's built, which is content retrievals with a payment network. We've got Will Scott from Protocol Labs Data Systems team talking about car file tooling. And then we have William from Ken Labs speaking about a data store and API for GraphQL query with pubsub support. So yeah, with that, we've got the intros done. A quick message to say that if anyone's got any questions throughout this, please put it on the Retrieval Market Slack channel, and then we can answer them asynchronously or after the meeting, and also others can get involved. Over to you, Zhenyang.
Good, thanks, Patrick. Let me just share my screen. Great. Hello, everyone. Maybe before the demo, let me just quickly introduce myself to people who hadn't met me before. So my name is Zhenyang. I live in Brisbane, Australia. I have been working as a research engineer in Pegasus Consensus for almost 4 years. I've been mostly involved in cross-chains, stateless Ethereum, a little bit on ETH2, and recently Filecoin retrieval and IPFS. So FCR is another secondary retrieval client that I have been personally building during the past 2 months. For the presentation today, what I will do is I will first go through only the core concepts of the system without covering other details, because it would take at least an hour to go through everything. Anyway, after the system walkthrough, I will then do 2 live demos. So first of all, FCR is written in Go, and it is able to participate in a CID network for content delivery and a payment network for payment delivery. So CID network is very similar to IPFS. So I will just quickly go through this slide. I assume everyone is familiar with IPFS. So routing is based on CAD-DHT. Provider record is used to indicate an interest of serving content. That is, if you use FCR to start serving a content, FCR will periodically publish the provider record to DHT until you stop serving. If someone else wants to retrieve a content, it will first use DHT to find the provider record. After provider record is found, FCR will query the provider for a signed CID offer. So this is a CID offer. It contains a few things: the root CID of the graph, the price per byte, the size of the graph, the wallet address for receiving the payment, plus a little bit more. One thing that I wish to mention is the linked miner in the offer. So the idea is that if you are running a Filecoin miner and you also wish to participate in the secondary retrieval market, you can attach your miner address together with a proof to your CID offer, which means this can combine with a proof of storage in Filecoin to increase the reliability of a CID offer. Also, potentially this can combine with the reputation system people are building. So you could imagine that CID offer with high reputation is more likely to be picked by others. So you could set maybe a slightly higher price. And this could also potentially further encourage people who run secondary retrieval clients to also run a Filecoin miner. Okay, so enough for the CID network. Let's talk about the payment network. So after you create a payment channel to someone, you can choose to serve the payment channel for others to use at a given price. The serving information in the form of payment routes, which I will talk about in the next slide. So the payment routes will be published to subscribers every certain period of time until you stop serving. If someone wants to do a proxy payment, it will first find a payment route, then use a payment route to query for a payment offer. Now let's introduce the concept of payment route. So in a network of 5 nodes here, the arrow is the payment channel being served, and there are 6 possible payment routes from node A, A to B, A to B to D, A to B to D to E, A to C, A to C to D, and A to C to D to E. So node A stores all the payment routes from it locally, so A knows which nodes are accessible from it. These payment routes will also be published to A subscribers. Normally, a subscriber is someone who has a payment channel with you. For example, node A will subscribe node B and node C for all the payment routes from them. So in the end, every node will know, all possible payment routes from it. For example, let's say node A wish to do a payment to node E. There are two possible payment routes that can reach node E: A to B to D to E, and A to C to D to E. So FCR will try to query for payment offer for each of the routes. Let's use A to B to D to E as an example. So A will query B for payment offer because B isn't the final node in the payment route. So B will query the next node in the payment route, which is D for payment offer. D is actually the final node serving the payment channel to node E. So D will reply with assigned payment offer to B. So this is a payment offer. Similar to CID offer, it contains some information. For example, it has price per period, period, and max amount. The price per period and period are used to calculate the surcharge. For example, for an offer with price per period to be 5 and period to be 100, in order to proxy 100 units payment, you need to pay 105. Okay, so node D replied to B with a payment offer. Then node B will create another payment offer that actually depends on the payment offer received from D. So the surcharge in pay offer B will include both the surcharge set by node B's user and the surcharge of pay offer D. So node A will then be able to proxy a payment to all the way to node E. So the payment is done again recursively, similar to query offer, after node B received a proxy payment request from A. Because pay offer B actually depends on another offer, so node B will use a dependent offer, which is pay offer D, to proxy a payment through node D. And after D receives the request, D will just pay directly to node E because pay offer D does not depend on any other offers. Cool, yes, so that's a very quick walkthrough of the whole system. I'm not sure if you can get all the ideas, but feel free to reach me on Slack if you have any question, or maybe you just want to know a little bit more on the system. Now let's move on to the demo. Okay, so the first demo is to show how retrieve a content with proxy payment in a 5-node network look like. So what I have done before this presentation is I spinned up a Docker Compose that is consisted of 5 FCR nodes and 1 mocked Lotus miner. So and I also run a setup script. So the network looks like what is shown in the graph. Maybe we can have a look at the setup script. So the first thing I did here is I did a bootstrap of these FCR nodes so they are connected. Then for every node, I generate some random files and use FCR to import those files into the system. I then asked these nodes to start serving those files with price per byte to be just 1. Last step is that I use FCR to create payment channels, then start serving the payment channel to the payment network with price per period to be 5 and period to be 100. Let's go back to the terminal. And you can see the output of running the setup script here. So node 2 imported 2 CIDs, node 3 imported 1 CID, node 4 imported 1 CID, and node 5 imported 1 CID. So this can be also shown, in the graph as well. Also, node 2 served a channel to node 3, node 3 served the channel to node 4, and node 4 served the channel to node 5. So if you understand this graph, let's assume we are node 1 here. Okay, so we are node 1 now. By using FCR, you get this CLI where you can access the CID network and payment network. For example, in the CID network, you can have access to the piece manager. Where you can import a IPLD graph into the system. So you can choose to import a regular file or a .car file. In addition to that, in order to make life easier for Filecoin miners, FCR supports importing IPLD graphs from unsealed sector. So if you are a miner and you enabled fast retrieval, then you can import all the pieces directly into secondary retrieval market by using import sector. By default, when you import a sector, FCR only stores a reference to the sector without creating another physical copy, just to save your disk space. Okay, now for that, let's focus on retrieval. So as a first step, what I'll do is I will retrieve one CID from node 2. And you can do this by using the retrieve API. So use the CID here. Let's retrieve it to the current directory. Okay. So we, as node 1, we found one CID offer through the DHT from node 2. Normally, if we don't have a direct payment channel to the recipient, FCR will find corresponding payment offers. However, as you see, node 1 does not have any payment channel to any other node. So we will have to create a payment channel. So let's do this. Let's use this offer and let's create a payment channel with a lot of balances. And the payment channel is created and the retrieval is done. So after we create the payment channel, the network will look like this now. And we now have access to every node in the payment network. So next, let's retrieve the other CID from node 2 and let's see what happens. Other CID. Okay, so this time, we also find the CID offer from node 2. However, how the retrieval works is that first of all, it will query all directly connected peers for offers without going into DHT. And we have just created a payment channel with node 2. So FCR queries node 2 for the offers first. And we found an offer, so we don't need to go into DHT stage. And let's retrieve using the offer from node 2. And the retrieval is done. Next, let's retrieve the CID from node 3. Okay, so this time we can't find an offer from node 2. So we discovered an offer via the DHT network, and we found an offer from node 3. However, because we don't have a payment channel directly to node 3, FCR searches for the corresponding payment offer. And because node 2 served the payment channel to node 3, we found one payment offer from node 2, and the payment per pair rate is 5 with a pair to be 100. Now let's retrieve the content using the CID offer from node 3 and the payment offer from node 2. And the retrieval is done. So you don't need to wait for the wait to create a payment channel. Next, let's retrieve the CID from node 4. And okay, so this time we found an offer via CID offer via DHT and the corresponding payment offer. However, this time the payment offer has a different price. The payment per pair rate is 10 with a pair to be 100. That is because this proxy payment goes through node 2 and node 3. So we need to pay surcharge to both of them. Let's retrieve, the retrieval is done again. So finally, let's retrieve the last CID from node 5. However, this time we're going to do something different. We will use faster retrieve instead of retrieve. So how fast retrieve works is that you only need to supply the max amount you wish to pay. Fast retrieve will first query directly connected peers for CID offers. If FCR can find the CID offer in this stage, it will choose to retrieve using the cheapest offer as long as the total price does not exceed max amount. If FCR fails to find the CID offer in this stage, it will query the DHT for CID offers, and for every CID offer, it will try to find all the corresponding payment offers as well. So among all of these offers, FCR will choose the cheapest CID offer and the pay offer pair, as long as it does not exceed the max amount. Okay, let's do this. Retrieve to current directory, and with max amount to be 0, which just mean no maximum. So and cool, the fast retrieval is done, and now we have all 5 CIDs retrieved from the network. So so that's it for the first demo, and the second demo is more interesting. It is a 10-node network. So similar to the last demo, I have got a Docker Compose up and running. I have also run a setup script. So the overall network looks like this. And each of the node is hosting a unique CID. So node 0 is hosting CID 0. Node 1 is hosting CID 1, blah, blah, blah. Node 9 is hosting CID 9. And the arrow is a payment channel as well. That means node 0 has a payment channel to node 1. Node 1 has 3 payment channels, one to node 6, the other one to node 4, and the last one to node 2. This has already been configured by the setup script. I have also configured the max hop to be 10, which means every node is able to access every other node. For example, it is possible for node 9 to retrieve a content from node 6. So proxy payment will go through node 8, node 5, node 2, node 3, 0, 1, and finally 6. So if you get the idea of this network, then we can start the demo. However, this time I won't do the demo manually. Instead, I will rely on a script to do that demo, that is run.sh. You may wonder why, because this time we're going to do something different. Maybe let's have a look at the script first. Okay, so this time what we will do is, first of all, we get the CID served by each node. Then we will ask every node to do a fast retrieval of every other CID from the network. So that is, say, node 0 will retrieve CID 1, CID 2, CID 3, all the way to CID 9. Node 1 will do the same, blah, blah, blah. Every node will do the same. So, and we make this retrieval concurrent. That is 90 total retrievals. So the idea is that every payment channel can be used by different people for different purpose. It can be used by you for retrieval, or it can be used by others for proxy payment at the same time. So let's run the script and redirect the output to a file. So retrieval hasn't happened yet. So the first thing is to load the CID from every node. And now retrieval is happening. Oh, not yet. Oh, they're actually happening right now. I think, yeah, you can see the log output from GraphQL. Yeah, somehow it is taking a little bit longer than expected, and you can see some retrieval fails, which is normal, and which is also expected. So normally you can see only one or two retrieval failed, but this time you see a little bit more than that. It's fine. If we have a look at the output file and we search for the keyword retrieval done, we can see that 72 out of 90 retrievals succeed, with 18 failed, which is a little bit high. Normally it's only one or two. Maybe that's because I'm also doing the video. So so if this happens, that is okay. You can run the retrieval script one more time. So for previously successful retrievals, FCR will retrieve the content from retrieval cache. So no network activity and no cost. But for failed one, FCR will just try again. But if previously the retrieval fails in the middle, you don't need to pay for already retrieved blocks because they will also come from the cache. It's just right. So this time you can see that the output message, instead of retrieval done through retrieval done, it is retrieval done through cache. And we finish all the retrievals. If we check the folder, for example, in node 9, we can see that it has 9 other CIDs retrieved. If you check other nodes, they all should have every other CIDs retrieved. We can also check how much was spent by inspecting the outbound channel, which I won't do today due to time. And yeah, so cool. That's all for the second demo. Thank you guys for listening. Feel free to reach me on Slack if you've got any question or comment or sort. Yeah, that's it. Thank you.
Thank you very much. That was great to see. There are some questions on Slack, so we won't go through them now. We'll move straight on to the second presentation, which is from Will on car file tooling.
Cool. This will be very short in comparison. This is just providing an update in this forum on some of the work we've been doing for IPLD and CAR, and some additional tools that are out there now that you can use when working with CAR files and CID data more generally. So I am sharing my screen, I believe, and where is this? Okay, can you see this? Hopefully, yes. So there's a binary. The binary runs as car. You can, if you do not have this installed, install it by running go get github.com/ipld/gocar/command/car. And a car is a CLI utility that works with car files. So for example, if I have just some random data and I made a folder here called example, and example contains a file called hello.txt, right? So I've got, some arbitrary folder directory tree. I can take that data and pack it into a car file by using car create and an output like out.car. And I can say I want to basically take the example directory and put it into out.car. And it's mad because there already is an out.car, but I will get rid of that previous one and do this again. Now I have a file that is out.car again. And I can do things like I can car list what's in out.car, and it'll show me the blocks that it's packed. I can do a couple additional things that are sort of useful here. I can list with Unix FS semantics. And now I can see that in there is the directory example and the file example/hello.txt, as you might expect. We also have a verbose mode that just gives you a bunch of additional details about this. So things like this block is using the raw codec, and then these other two, which are the Unix FS metadata, are DAG-PB encoded. And you can see that this one is a directory that contains example, and this one is the directory entry that has hello.txt as a file. So you get some sort of detailed structure about what's in there. The car that gets packed here is a car v2. The car, which means it has an index so that you can do random access reads on it. The car binary also has options for being able to do things like detach the index, to remove the index, and get the previous carv1 out of it. One of the things that you can expect soon is that we will, and likewise, you can extract either specific CIDs or specific subdags out of a car. And one of the other things that we're working on that you can expect this CLI tool to help with soon is it'll be able to calculate what the canonical comp over a car would be, which will basically stream the car in selector order through a comp process so that you get what that hash is going to look like for that car. The thought is that these carv2s work just as well in whatever order they happen to be in because they have the random access read over them. So you can use this as your data store, and then you can also use it as a source for a GraphSync style transfer. So we've got that creation and stuff. You'll also expect, and we're working on an extract where you'll be able to go back from these car style formats to the Unix FS directories directly. That's what I've got. Happy to answer questions. Feel free to make use of this as you deal with cars and data through Filecoin and IPFS. Thanks.
Great, thanks, Will. Yeah, please add any questions to Slack if anyone's got some. Final presentation for today is from William at Ken Labs. Over to you, William.
Thanks, Patrick. Okay, so let me share my screen. So today I'm going to introduce you the service we are building. So the Dearbot metadata service. In this demo, we will show you the POC. But before that, I'm going to talk about the motivation. So the idea is that we want to aggregate all the metrics from multiple Dearbots so that we can provide a reliable and performant query service for different consumers. For example, if you want to collect the metrics and work out some score for reputation purpose, that's the way you, or the service you can try. So this is simply the motivation. And the POC, in terms of the POC, for now, the Dearbot has no notification enabled, so that if we want to receive any update in the real time, we need to do some work in the Dearbot. At the same time, we are working on some mock, so that we will mock the data produced by Dearbot, and also the mock server will also serve some sample data so that the service can collect the query the data and get it cached so that it can be served by our GraphQL API which will be used by any consumer, in this case by ourselves. So I will use the browser to show you how to query. Okay, so I just launched the daemon here, so you can see the service application running this module address and the peer ID. And we also have the GraphSync and the GraphQL servers on different ports. Let me confirm the peer ID. Okay, so I need to change. This is a more provider, and we haven't done very rich features in this mock provider. So I need to manually change here so that it can connect to the correct peer. Okay, as the daemon is started, I need to use this call to trigger the subscription. Okay, it's down here. So you can see the log here shows that it's the data transfer module. This is the indication that the subscription is done. Okay, now what I need to do is use the provider. If I run this provider, it will produce some data. So these are the sample data we use and produce. In theory, we should see something print here. Yeah, you can see. So we received some response, and this is a CID received. And if we go back to, so this is all the logs for the data exchange. And if we go back to the provider, we can see for these sample data, we have the CID generated for each route. Now, if we copy any of them, say this one. So this is the false. So it maps to 3300, the test miner. We go back to the GraphQL interface. So this is a HTTP server we run on port 9005. We use this ID and try to query. So you can see the test miner 3300. So this is what we were looking for. We can also try a different CID. So this is for, so it's not very well printed. So in general, this is the first one to 8081. If I copy and paste here. So this is a 8081. Okay, so this is a simple example. The idea is that we want to set up the end-to-end data flow. The service can subscribe to the data change or the DAG update so that we can query offline. So this is like a sync mode. We can query offline to the data producer or the dearbot in this case, and collect the updated metadata, get them stored or cached. We will also aggregate them for future usage. In this way, all the data collected will also be then served over the GraphQL or HTTP API or over the GraphSync interface. So that's part of the next step. So in next step, we will implement the DAG update notification in dearbot so that the dearbot can integrate with this service. And for now, we haven't done the aggregation. So all the data received are simply cached locally in the memory. And the data, of course, in the data store from the provider side. And this is what we need to do, the DAG aggregation and IPLD data store for local storage purpose. And yeah, I think that's it for today. We will bring more features in next 2 weeks. Yeah, I believe it's, yeah, the QA will go to Slack. Thanks. 谢谢.
Great, thank you very much. Xie. So at this point, has anyone got any questions which they'll think would help those watching the recording to understand any of the talks? We'll have those questions first. We'll stop the recording and then we can go to a more informal conversation afterwards. So yeah, anything which we think could help clarify or explain any of the talks. Cool. Sounds like we're all good. So we'll wrap up the recording there. Thanks, guys. They're really great recordings.